Dear students, in today's module, we will discuss logic operators. As you know that arithmetic logic unit performs variety of operations. For example, arithmetic operators, logic operators, and using shift operators. We have already learned about arithmetic operators. However, in today's module, we will be mainly focusing logic operators. So logic operators which are available in computer are bitwise operators like AND, OR, exclusive OR. Such operators were slightly discussed in one of the module, but we did not have enough examples and we were not able to see that where actually in reality they are being used within the computer. So today we will having a small revision of these modules. So for example, if there is an AND operator, you know that we have 2-bit patterns 1 0 0 1 0 0 1 and we have 0 1 1 1 0 0 0. So you know the logical AND gate performs whenever we have 2 bits 1, then it will give you 1, otherwise it gives you 0. And similarly, you might recall that the OR operation was if we have similar bit pattern. So this will give you 1 when any of the input is 1 or both of the inputs are 1. But it will give 0 when both of the inputs are 0. And then there was exclusive OR. And this exclusive OR was giving you the value so if any of the inputs are 1, it is giving you 1, but for both of the inputs are 1, it is giving 0, or both of the inputs are 0, it is giving 0. So today, after revising these concepts, we will apply these concepts in real examples. So let's see, let's see how these operators can be performed in real examples. For example, there is one situation that you want to place zeros in one part of the bit pattern while not changing the others. So for example, you have a bit pattern like 1 0 0 1 0 0 1 1 0, and you want to place zeros, for example, to these 4-bit patterns, while you don't want to change these 4 patterns. So what you can do is you can put an AND with a number that is 0 0 0 0 1 1 1 1. So let's see the answer. So 1 1 would be 1, 1 1 would be 1, 1 0 would be 0, 1 0 would be 0, and all of these bits would be 0. So you have seen that this was the actual number, and we have changed the first 4 bits of this number to 0, while the next 4 bits remained unchanged. So such a situation we need when, for example, we want to eliminate red from the RGB. So you know, in RGB we have 3 bytes. 1 byte is reserved for red color, 1 is for green color, and another is for blue color. So if we want to eliminate the red, we can perform such an technique which we have done here by putting all of the zeros in the red column and 1 to the all of next columns. So such a technique is basically called masking. So we can also perform such things in, like, there are 16 bits showing the availability of ice cream flavors. So for example, we can make it a little bit smaller example of 8 bits. Like we say 1 0 1 0 1 1 0 0 1 2 3 4 5 6 7 8. So for example, suppose this is these are the 8 bits which are representing which flavor of ice cream is available at the moment. So 1 is showing that this is available, 0 is showing that this is not available. So this is available, this is not available, and so on. So suppose our first 4 flavors are actually finishing, so then you will be ending it with 0 0 0 0 1 1 1 1. So this would make these initial 4 bits as 0, and the next 4 bit will remain unchanged as it was in the question. And similarly, when you want to find out whether particular flavor of ice cream is available or not, so you can also check by ending it with 1. So for example, we have 1 0 1 1 0 0 0 1 1 2 3 4 5 6 7 8, and we want to check whether this kind of flavor is available or not. So you can end it with 1 0 0 0. So you would see that on this 5th bit from left side, it will be 1 only when there is a flavor available, otherwise it will be giving you 0. And then, for example, when to use OR. So putting 1 at designated bits in the bit pattern without changing the remaining. So you can do it using an OR operator. And similarly, you can use such a mask using AND to make sure that 3rd bit becomes 0, because other are 1 and they will not change the remaining bits of the input. And similarly, you can use this mask to actually make it sure that the 3rd bit becomes 1 and other bits remained un-0. So let's see, for example, you have a bit pattern 1 0 0 1 0 0 0 3 4 5 6 7 8. So for example, we want to make this bit as 1. So you can put 1, other zeros, and you can perform OR operator. So you know it will become 1 and others will remain unchanged, whatever it was in the actually available in the input. And there is a very interesting concept for XOR. So XOR can complement a bit pattern straight away. So for example, if you have a bit pattern 0 1 1 0 1 0 0 1, so you want to complement it, you want to make zeros as 1 and ones as 0, you can simply XOR it with 1 1 1 1 1 1 1 1. So let's see what would be the output of exclusive OR. So you know it gives 0 on the same bits and 1 on the different bits. So you can see the actual input which we have given has been totally changed, complemented. All of the zeros have been changed into 1 and all of the ones have been changed into 0. So such technique you can use to invert the images. So for example, if you invert the image, you want to make black into white and white into black, then you can use such an exclusive OR operation. So if we conclude today's module, we have learned interesting examples that how logic operators and OR, exclusive OR, actually can help us to solve real problems in computer science.